right, we are back. This is Techmath2. We're looking at the Red Book, section 6.5, adding and subtracting radicals. We're on page 268. So let's take a look. So before we start this lesson, let's remember when we added up like terms in the past. If I had 5x plus 3x, I wouldn't change the x. I wouldn't change the power on the x. I would just say 5 plus 3 is 8. And then I would put the x down. All right? So that's exactly the same concept that we're doing now with this. Okay? So take a look. 5 cube roots of 3 plus 6 cube roots of y. Rather, I said 3. 5 cube roots of y plus 6 cube roots of y is just 5 plus 6, which is 11. And then see, x and x, that just stayed x. The cube root of y and the cube root of y just stays the cube root of y. So you just don't change it at all. Just like when you added like terms with variables, it's just a tiny bit more complicated because sometimes it looks like this with numbers. With the variables, it's actually not bad. It makes a lot more sense. It mimics that. But this, you've got to fight the instinct to subtract 3 from 3. We're not doing that. It's just 4 minus 9, which is negative 5. And then the square root of 3 just stays exactly the same, square root of 3. So when there's numbers in there, I think it's a little harder because instinctively we want to change the number, but don't. It's just the coefficients, just the number in front. All right? So 9 square roots of t plus, remember, 1 square root of t. When there's nothing there, there's a 1 there. So that's 10 square roots of t. The cube root of 3x plus the cube root of 3x is 2 cube roots of 3x. Because remember, that's like 1 cube root of 3x plus 1 cube root of 3x. So it's 2 cube root of 3x's. The fourth root of y minus 3 fourth roots of y. Remember, that's a 1. 1 minus 3 is negative 2. And then fourth roots of y. And the square root of 10 minus the square root of 10 is 0. 1 square root of y plus 7 plus 1 square root of y plus 7 is 2 square roots of y plus 7. Again, do not make that 2y plus 14 or something. That's the most common mistake I've seen in my career because unlike this, you know, this basically counts as a variable, just like that did with the x's. All right? 12 fourth roots of p plus q minus 5 fourth roots of p plus q. That is 7 fourth roots p plus q. Oh, I'm sorry, I didn't tell the number. So that was 45. This is 46. That's right underneath it. And then 47. So these were all three kind of right in a row on page 268, 269. Then let's skip to 52. And this one's important because you cannot take the square root over a plus or a minus inside. So look, that is a perfect square, minus a perfect square. But when they say simplify, you cannot. That is simplified form, basically. Y squared minus 25. The square root of y squared minus 25 cannot be simplified. That is different than this. This is being multiplied. This can be simplified. You take the square root of 25 is 5. You take the square root of y squared, that's y. So that one can be simplified down to 5y. All right. This one cannot be simplified, because you've got p squared plus q squared. You can never, ever, never take a square root and distribute it over a plus or a minus sign. All right? But this, d, those are being multiplied, so you can do the square root of p squared and the square root of q squared and write them both down. So that's pq. Okay? So be careful on those. Those are tricky. That's why I worked that one out. All right, let's look at 6.6. Let's jump to 54. So we're looking at raising powers. Remember, when you have a power raised to a power, you multiply the powers. So you get the square root of 1/5 squared. Okay, so basically what this is going to do is just going to be 1/5. Because remember what this is. This is 1/5 to the 1/2 power. And then squared. Well, when you have a power raised to a power, you multiply. So remember how we multiply? Top times top, bottom times bottom with fractions. So it's 1/5 to the 2/2, which is 1/5 to the first, which is just 1/5, which is what I put there. So basically, like a square root and a squared, they cancel each other out, and you end up with just what's inside. All right, let's take a look at B. We've got the square root of x minus 8 quantity squared. So that square root and that squared just going to wipe each other out. You have x minus 8. C, the square root of AB over CD. Quantity squared is just AB over CD. So the square root and the squared kind of cancel each other out for this reason. I'm not going to do that every time. All right, that was just kind of the explanation for it. And so that is pretty much the same. Let's jump to 62. We got the sixth root of 7 raised to the 6th power. So in the same way that the square root and the squared wipe each other out, the 6th root and the 6th wipe each other out. And just a 7. The 7th root of 2d raised to the 7th power. That's just going to be 2d, just the thing inside. And the 9th root of this pq, or pq, raised to the 9th. That's just pq. All right. All right, let's look at 6.7. That's multiplication involving binomials. So again, I'm hoping a lot of this is just a review, right? We've seen this before. We've had a former algebra class where I'm sure this was covered. I'm just trying to get the rust worked out of the cogs here a little bit. So 6.7. Let's jump to number 66. We got the square root of x plus the square root of 7 times the square root of y plus the square root of 2. So remember, there's two ways to do this. If you had me in 115, I explained both ways extensively. But you can FOIL first order or last. If that's how you know it, that's fine. But at the end of the day, what you're doing when a binomial times a binomial, you're doing the distributive property twice. So that's this times this times this, and then that times that, and that times that. So the square root of x times the square root of y, they're both under square roots. So you can put it all under the same square root and say the square root of xy. The square root of x times the square root of 2. They're both under square roots. You can just say the square root of 2x. Square root of 7 times the square root of y, both under square roots, square root of 7y. And the square root of 7 times the square root of 2 is the square root of 14. And now, unlike most FOIL problems, first order and last, usually we could add up like terms. So in this case, there's not one like term amongst any of these. And none of them can be simplified. There's no perfect squares in any of them. So that's it. That is the answer. Just kind of a tedious little problem. Let's look at 68. See if that gets a little better. So we have 10 square roots of 3 plus 7 times the square root of 3 minus 3. So this one we might have a little more luck. So let's take a look at what happens. We have 10 square roots of 3 times the square root of 3. So you can take the square root of 3 times the square root of 3 and get 10 square roots of 9. You took the 3 times the 3 under the square root side. 10 square roots of 3 times negative 3. That is negative. You could take the 10 times the 3, 30 square roots of 3. 7 square roots of 3 and negative 21. Now, I've had students say, wait, Mr. Pledgey, you told us we can't add up unlike terms, so what are you doing? You can't multiply 7 times the square root of 3. But you can. You can multiply anything. You can't add anything. Now, like this, I can add to that because they both have the square root of 3. But I can't add this. Well, actually, I can add that to that because the square root of 9 is going to go away. But I can't add this to this because those are different, okay? So let's do the square root of 9. That's just 3, regular 3, right? So that's just 30. So I have 30 minus 30 square roots of 3 plus 7 square roots of 3 minus 21. So now look, 30 and negative 21, we can put those two together. Those are like terms. So that's 9. And negative 30 plus 7 is negative 23 square roots of 3. So 68, that was 9 minus 23 square roots of 3. But that was some work. This one was actually a little easier because nothing ended up being where you had like terms that you could add. All right? But you can multiply anything together. So just a quick reminder, 5x plus 3x, those are like terms. You could add them together and get 8x. 7x plus 2y can't be added because those are unlike terms. But if I say 7x times 2y, I can do that. That is 14xy. So you can multiply anything, whether they're like terms or not. You cannot add anything. You can only add up and subtract like terms. All right? Okay, let's do one more problem off of that set, number 70. And these are special also. These actually have a special name. They're called conjugates. Number 70, they have us multiplying conjugates. And let me explain what a conjugate is. 2 plus the square root of x is 2 minus the square root of x. Conjugates, you know, I've had students in the past go, you math people, you make everything hard. That's just opposites. No. Opposite of this would be negative 2 minus the square root of x. Only one of them changed the sign. And that's what makes it a conjugate. Okay? So look at what happens when I multiply conjugates. A binomial times a binomial. But they're conjugates. 2 times 2 is 4. 2 times the square root of x is negative 2 square roots of x. The square root of x times 2 is plus 2 square roots of x. And again, I've had students ask that question. They're like, well, wait, why isn't it the square root of 2x like it was on the one that I just erased? Well, that was the square root of x times the square root of 2. And then you'd have the square root of 2x. If the 2 is on the outside, you can't really multiply it with the x. It just kind of goes out front. Just like how I couldn't multiply x and y. I just write them next to each other. That's what's going on there. And then now look, the square root of x times the square root of x, those are both under square root signs. So I can take x times x and put them under there, x squared. All right? So now look at what happens with my conjugates. I have 4, that's just going to stay 4. There isn't any other just regular number for it. But negative 2 square roots of x plus 2 square roots of x, that's 0. And then minus the square root of x squared is just x. So we end up with just 4 minus x. No square roots at all left in my answer. They all went away. Let's get another conjugate. We got the square root of p plus q times the square root of p minus the square root of q. Oh, square roots on each of them? Square root of q, sorry. Make sure you write down the problem correctly. Okay, so now look, everything's under square root here. So we got the square root of p times the square root of p. That's the square root of p squared. We got the square root of p times the square root of q. That's negative square root of pq. We got the square root of q times the square root of p. That's positive square root of pq. Or qp, doesn't matter which order you write them, but whatever you pick for this one, do it the same for that one. Remember, order doesn't matter for multiplication. So it's easier to see they're like terms if you have PQ both times instead of PQ and QP. Minus the square root of Q squared. And now again, look at what happens. I have negative square root of PQ plus square root of PQ. So those cancel away to 0. And the square root of P squared is P, and the square root of Q squared is Q, and there's still a big fat minus in between. And that's it. So when you're working with conjugates, the middle term will always, always, always cancel away. All right? Okay, let's see how much time we have left here. Okay, we'll call that a video.